Hey audience, last time I talked about buffering signals into my LEDs, and I ended up doing some things that I didn't mention in that video, so this is a brief update about that. One problem is that I wanted my LEDs to be wired in reverse to the inverters that I'm using as buffers, but I realized that I'd accidentally wired all of the cathodes common instead of all the anodes, so I had to take all of those out and rewire them reverse of the way that I had them wired up. I was really dreading this for a while because of how hard it is to solder things inside the angled front panel of the box, especially when all those switches and wires are already in there. Then I realized I could just stuff the LEDs in the front of the case and solder them together before taking them out, and then popping them back in from the inside as a single unit. I think I've been spending too much of my time writing software where things become real just by writing them. Now that I've been building more physical things, it's been teaching me to think not just about how the things I want should work and look, but to think about how to physically construct them as well. Also, this is way more soldering than I've done for a single project in a long time, and I've learned that I really should have just designed a PCB and had that sent out to be made for me. Oh well. Another thing is that I want the LEDs to be off when there are no wires plugged into them, which means that the inputs to the inverter buffers should be low when nothing is plugged into them. TTL gates can be pulled high pretty easily with a fairly high value resistor, but it's generally harder to pull a floating TTL gate low. You need a smaller resistor, which will end up pulling more current. That draws more power, but more importantly, pulling more current means having a pretty big effect on the circuit that I'm probing, which is the thing I'm trying to avoid in the first place. So instead of using TTL gates here, I'm using a CMOS version, the 74HC04. Inputs to the CMOS gates are basically just capacitors, so they don't let any current flow in steady state, unlike the base terminal of a BJT. With these, I can pull the floating inputs low even with some dummy thick 100 kilo ohm resistors. Something to keep in mind though is that now I can only ever put CMOS chips in these sockets. With the debouncing flip-flops, I could put any kind of 7437 in there. S37s, LS37s, HC37s, plain vanilla 7437s, and they would all work fine. But that's not the case with these inverters because of the pull-downs. I wouldn't design an actual product this way for this reason, but it's fine for this. So now I can finally add a clock and talk about clock multiplexing, so I'll do that next time. I'll see you then.